Lesson 4.8, Solving Equations Using the Quadratic Formula. So now that we know what the quadratic formula is, we need to look at how we can apply it. So let's look at this first equation. Please write this down and do it with me. X squared plus 3x equals 2. I've learned two methods so far of solving quadratics. The first one is factoring. So I could subtract my 2 and see whether or not it is factorable and continue that way. I cannot use square roots, and that is because of this middle bx term, so that immediately eliminates square roots. The third method that we're talking about now is the quadratic formula, and we're going to go ahead and try that method. To use the quadratic formula, we're going to start the same way we would if we were factoring, and that is to set it equal to 0. So that's going to give me x squared plus 3x minus 2 equals 0. Since I look and see that my leading coefficient is 1, it might be worth the time to check and see is it factorable, because I can use the easy method. For it to be factorable, I need to think of two numbers that multiply to give me -2, add to give me +3. And in thinking through that, there is no way to factor this quadratic equation. Therefore, my only method at this point is the quadratic formula. When you first start using the quadratic formula, it might help you to actually list what A, B, and C are. In this case, A is 1, B is 3, and C is -2. That way we can quickly reference what we're plugging in. Just to recall, the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and plug some numbers in here. The opposite of b would be -3 plus or minus the square root of 3 squared minus 4 times a times c all over 2 times a. Let's go ahead and simplify this a little bit. That's going to give us -3 plus or minus the square root of 3 squared is 9. This position right here under the radical will always be positive, no matter if b is +3 or -3. This number will always be positive. If it is not, then you squared incorrectly. What I do from here is I count the negatives, because when you do the quadratic formula, the chances of making a simple mistake are very high, considering all the multiplying and squaring and dealing with positives and negatives that we're doing. So I count the negatives. I see here is 1, here are 2 negatives, which means I'm going to be adding that number in there. If I have an even number of negatives, I'm going to add. If I have an odd number of negatives, that sign is going to stay subtraction. Now I simply multiply the numbers. 4 times 1 times 2 is 8 over top of the denominator, which is 2. That's going to give me x equals -3 plus or minus the square root of 17 over 2. These are my two solutions. I notice that it is two real solutions because 17 is positive. And I also realize that I cannot break up root 17 at all. If I wanted, I could write it as -3/2 plus or minus root 17 over 2. And that also is acceptable. From here you can find the decimal values and then graph it and make sure that your x-intercepts correspond to the decimal values that you find.